everyone, welcome back again. And this time, let us start talking with another very critical concept, file permissions and UMask. So when we talk about file permissions, what are these? When you go and check any file details, it would display some information to you like this: the nature of the file and the file access permission. So this part, what you see on the screen, it is called as file access permission. Now, according to this, either someone will gain access to the file or will be restricted from getting access towards this file. So let us understand that what are these file permissions and how we are going to assign them. So file permissions are applied on three levels: owner or user level, group level, or others. Now, owner is someone who has created the file. Like in this case, as root has created the file, so root is the owner and root is the group owner. In Linux, there is a user which is root, and there is also a group that is called as root group. So this file in this case belongs to root as a owner or a user, and root as a group owner of the file. Now, one user can be the owner of the file, and one group can be the group owner of the file. But you see, in the system, we have several other users, several other groups that exist in the system. So all those other users, all those other groups will come under the category of others. So you can use owner or user, group owner, and the permissions can be given to rest of the others. And what type of permissions we can apply? You can apply read permission, write permission, and execute permission. Now, what is the effect of read, write, execute on a file and on a directory? If you apply read permission on a file, people can open the file or they can view the content of the file. Same way, if you apply it on a directory, people can list the content inside the directory. They can see how many files and how many directories are present inside it. And if you give write permission, for write permission, people can make changes in the content of the file, or even they can delete the file. Same way, on a directory, people can add, delete, rename the content inside the directory. So basically, write permission will give access to the users to make changes in the file or to make changes in the contents of the directory. Lastly, we have execute permission. This will allow people to run the command or shell script. See guys, execute permission on a file is not generally required. Execute permission is required on a file if the file is a special executable file, which is called as scripts. So if your file is a script, so in that case, we require execute permission. Otherwise, we don't need execute permission at all. And in case of directory, it is very important. You cannot enter into the directory if execute permission is not given. So execute permission is really important when it comes to directory, but on the file, it is optional and only needed if the file is a special file that is called as script. Now, how to identify what permissions are assigned? Like in this case, you see there are three permissions, what it is showing, three set of permission. So first set, what you see over here, the first set of permission, 1, 2, and 3. These three permission belongs to user or the owner, which is root. So root can read as well as write the data into this file. Next three permission belongs to group. So group can only do read permission. That means this root, the root group is only allowed to read the thing. It cannot make any changes inside it. The last three permission belongs to others. Others are rest of the other world. All the other users, all the other groups that exist in the system, they are all can read the content and they cannot do anything else apart from that. So every level can get three access: read, write, execute. So in this case, we have given read, write, no execute. Then for group, only read, no write, no execute. And for others, only read again, but no write and no execute. Let us say I wanted to change these permissions. To change the permissions, you can use symbolic method or you can use absolute method. Symbolic method is to use symbols like U for user, G for group, and O for others. So here we use the command chmod to change the permission. Next, you have to give who. Now, who can be U for user, G for group owner, and O for rest of the other world. Plus if you are adding the permission, and minus if you are removing the permission, and equals is to totally change the permission. Let me show you how we can use this option. Let us say that I wanted to assign this set of permission. On any file, I want to apply for user read, write, execute permission. Then I have a group for whom I want to give read and write access, and there is others for whom I want to give only read access, for example. So how I'm going to achieve this concept? To get this, we'll use chmod command again. I'll say chmod for user, I want to give read, write, execute command. Now it's not yet over. I have to give it for group and others also. So I'll use comma. For group, I want to give read and write access. And for others, I want to give read. So you see for user permission, comma, group permission, comma, and for others equals to whatever. On which file? The file name is heart. Now, if you check, the first three permission belongs to root and we have given full permission. Next three permission belongs to group and we have given read and write. And last three permission belongs to others and we have given read permission. Observe one more thing. Earlier, the color of the file was black, but now it is having green. You know why that green color has been added? See if any file have execute permission inside it, either for root or either for a user or a group or other. In any case, if there is an execute permission, the file color will change to green, thinking that it might be a script. Anyway, now let us say that on one level, I wanted to remove the permission, and on the other level, I want to add a permission. Maybe from user, I want to take away execute permission, and for others, I want to add write permission. How to remove a permission from one level and add the permission on the other level? We'll go with chmod from user minus execute permission, comma, and from group, I wanted to plus or add the right permission. On which file? Hard file. So observe here, from the user, earlier there was execute permission, but now it is removed. And for others, earlier there used to be, for group, there used to be a write permission, which is still there. I made a small mistake. I'll say chmod. For others, I wanted to add a permission. Now you just check it out. So you see earlier others was not having write permission. Now it is having write permission. So on one level, you can add something. On the other level, you can remove something. Or if you want the same set of permission to everyone, then you can say chmod ugo for users, groups, and others. I wanted to set the same permission read and execute. On which file? Hard file. So you see user is having read and execute, group is having read and execute, and others are also having read and execute permission. Same way, let us say I wanted to apply full permissions. User to get full access, group to get full access, and others to get full access. To apply full access, you can say chmod ugo, or there is a shortcut A. A represents all users, groups, and others. For all, I want to give read, write, execute, on which file the file name is hard. Now, if you just check it out, you see it is having full permission. Now, if you want to remove all permission, suppose I want a file with no permissions, so you can again say chmod A equals no read, no write, and no execute permission. On which file? Hard file. So if you check, the file does not have a single permission at all over here. So this is the way how you can apply the permission and how you can remove the permission using symbols UGO. Now there is a quick fire method that is called as numeric method. So if you go with numeric method, for example, the numeric method or absolute method, what we use, it uses some numbers. Like read is represented by 4, write is represented by 2, and execute is represented by 1. So 4 for read, 2 for write, and 1 for execute. Suppose I wanted to give this permission. So how I'm going to attach it? You need to put 4 for read, 2 for write, and 1 for execute. Now if you add it, 4 plus 2 plus 1, what it becomes? It becomes 7. Then read and write, 4, 2, add it. 4 plus 2, it becomes 6. Only read permission if you want. There's no calculation required. It's just a 4. So what's the number I got? 764. Let me use that number. I'll say chmod 764. So first number for user, second number for group, and third position is for others. On which file? The file name is hard. If you just check out the detail, you see for user, we've got read, write, execute. For group, read, write, and for the others, read. So quick fire in a fast pace, if you want to apply the permission, then going with numeric method would be a very, very great idea. Same way, if you wanted to give full permissions or any other modification, suppose here I want read and execute permission. So read is 4, execute will be 1. 4 plus 1, it becomes 5. Suppose in the second level, I want read and write, so same. In the third level, I want write and execute. So in this case, I'll be going with 2 plus 1. That would become 3. So what's the number I'll be getting here? 5, 6, 3. Use this. I'll say chmod 5, 6, and 3 on hard file. Now, if you check the detail, read and execute for user, read write for group, and write and execute for other. So this is the way how you can change the permission using numbers. If you want to assign full permission, then you can say 777. 7 for user, 7 for group, and 7 for others. On which file? The file name is hard file. Now, if you just check it out, the detail, you see full permission has been assigned. So this is the way how we can apply full permission. If you want, you can remove all the permission 0, 0, 0, and you see it's going to remove. If you just check it out, all the permissions have been removed. Now, let's say, guys, I create one file. Let us say, just randomly, I'm going to create one file with the name called um, Apple, for example. If you just check the details about Apple, you see by default the file is created and it got some permission. Now my question is, who have assigned this permission? I never told to assign this permission, haven't I? I just say create a file, it created the file. But how come the file got automatic permission. This is called default permission. And default permission will be assigned by using a concept called UMask. UMask actually stands for Unix File Creation Mask. It's a 4-digit code that is going to apply default permission. So let me check it out and show you how these things will be working. See guys, when you run umask command, it gives you some number 0022. In this case, I'll request you to ignore the first digit and concentrate the last 3 digits. Let's calculate that how this fellow is giving us the file permission. So let us calculate default file permission. What is the maximum permission you can apply on any file? 777. 7 for user, 7 for group, and 7 for other. Now, in this case, there is a rule in Unix and Linux that no file can get by default execute permission. And there is a reason for it. See, execute permission on a file is not generally required. It is required when you are creating a script. And whenever you create a script manually, you have to give execute permission. So execute permission is not allowed by default on a file. So what are the other permissions I'll be getting now? If I remove execute permission, it becomes 6, 6, and 6. Now from that 6 value, if you minus the umask value, that is 0, 2, and 2. So what is the answer you're going to get? See, in this case, 6 minus 0 will be 6, 6 minus 2 will be 4, 6 minus 2 will again be 4. Now, if you open it up, let us say I want to open it up. So I'm going to say 6 can be written as 4 plus 2. Now you can argue me saying that 6 can be 3 plus 3 also. But guys, here are the three basic numbers only on which you have to open it up. 4, 2, and 1. You cannot use any other number. So 6 to be open will be 4 plus 2 only, where 4 stands for read and 2 stands for write. And again, there is a 4 that is read. One more time, there is a 4 that is read. So what's the permission I'm getting? Read, write, read, and read. Now, if you go back and check the apples detail, you will find out that it is read, write for user, read for group, and read for other. It is the same thing what you're calculated. The same place if you want to calculate the default directory permission. So what it would be, let's calculate it. So this time I'll go for default directory permission. So in this case, maximum permission allowable is 777 and directly you can minus 022. See, in this case, there is no rule that directory should not get execute permission. In case of directory, execute permission is very important. Without giving execute permission, it is not possible for you to go into the directory. So execute permission is required in this case. Now, if you calculate it, 7 minus 0 will be 7. 7 minus 2 will be 5, and 7 minus 2 again will be 5. Now, if you open it up, 7, you can write 4 plus 2 plus 1. So that would be read, write, and execute. Then there is a 5, which we have to open 4 plus 1. That would be read and execute. Again, there is a 5, so you have to again write 4 plus 1. That would become read and execute. So what is the permission you are getting over calculation? Read, write, execute, and read, execute. Now, if I create a directory, mkdir, for example, red, if you just check ls-ld red, so you will find that here it is going to get this permission. Read, write, execute, read and execute, exactly what you have calculated. Now guys, if you want, you can change the umask value, but it's not recommended in all the cases to change the umask value. Suppose the umask value is 022, you can make it 0 044, something of your choice. So it will work with that. But I don't recommend changing the UMask. You can just calculate the same way how we have calculated previously to find out what permission 044 will give you. So I'll play with UMask value and I'll bring it back again to the default value. So this is how we work with this particular concept. And this is all about your basic commands. In the next video, we are going to start with some important advanced level commands to be used in Linux, different Linuxes, in fact, like Red Hat or Ubuntu, etc. Thank you very much for watching this video. Hope to see you soon in the next video.